Cata, muy buenas tardes. Vamos a darle un poquitito de volumen a la música esa de NASA. Ya estamos conectados a la conferencia. Empieza en 14 minutos. Si el ex senador Bill Nelson llega en hora, ¿no? La otra vuelta hubo que esperarlo en una de las conferencias, me acuerdo. Esta vez va a estar Bill Nelson en la conferencia de prensa. ¿Qué es lo que vamos a ver? Bueno, la verdad no lo sé, no lo sé. Lo interesante de esta conferencia sobre el impacto y desvío del asteroide Dimorphos, recuerden el 26 del mes pasado, llegó, lo transmitimos, impactó ese asteroide que está girando alrededor de otro y que no son peligro para la Tierra en ningún momento. En realidad era para validar datos matemáticos de cómo podrían llegar a desviar un asteroide que sí sea peligroso. Bueno, un observatorio español hace una semana más o menos publicó algo de que tenían números preliminares pero no estaban confirmados. Este, recuerden que da una vuelta cada 11 horas y algo. Entonces, para poder tener confirmación, hay que hacer mediciones, muchas mediciones, compararlas, y no es fácil medir un tránsito de 11 horas de la Tierra cuando estamos girando, ¿no? Eh, yo me imagino que hoy, que ese panel del cual vamos a participar como prensa, que estamos acreditados, que está la Agencia Espacial Italiana también, que fue la que hizo la, el cubo, que filmó desde afuera ese satélite cubo, que nos dio algunas imágenes que no eran lo que yo sinceramente esperaba, pero igual, para estar a 11 millones de kilómetros fue genial. Y hay un panel donde van a estar el director de Ciencia Planetaria de la NASA, un científico del programa DART y la gente de coordinación de Johns Hopkins también. Me imagino que deben tener noticias importantes. Obviamente no dijeron nada hasta ahora, es parte de la expectativa y como corresponde hoy y siempre, paso a saludar. Primero veo a Rubén en el chat, dice bienvenidos, buenas tardes. Fernando Castañón, que dice la espera de noticias a este respecto. Manuel Gutiérrez Valdés, que saluda también, gracias maestro por avisar. Manu GP, gracias. Gracias por esa animación increíble que tenemos del astronauta que nos hizo el caricaturista argentino Alonso. Ibiza Bambán, Antonio, hello. Estás hablando inglés, Antonio. Escándalo tuyo. Luz Aval, que también saluda. Héctor González, Jorge Pitalá. Vamos, Master, dice Antonio. Quique Martínez, que también saluda. Marina Sánchez. Hablando de Marina Sánchez, perdón, no es respecto a ti. Me acordé del tema mujeres. Duplicamos la cantidad de mujeres que hay en el canal. Entonces, como suscriptoras y gente que nos mira. Eran muy poquitas, muy poquitas. Siguen siendo pocas en relación a la cantidad de hombres. Pero lo interesante es que esa cantidad se ha duplicado en los últimos 3, 4 meses, lo cual me encanta. Sinceramente me encanta que haya más participación femenina en esto que hacemos. Así que felicitaciones. Recuerden que cuando veamos la conferencia vamos a estar desfasados en el audio con lo que aparece en el video. ¿Por qué? Porque el video viene por internet, lo estamos capturando del canal de NASA, y el audio viene vía telefónica, donde estamos ya conectados a la conferencia de prensa. Entonces no tenemos forma de equipararlo, habría que hacer algún invento, y la verdad no estoy para tratar de hacer inventos de emparejar el audio con el video. Dos canales distintos. y esa música de ellos. Estamos a 9 minutos mientras vamos a poner un poco de blues, ¿no? Mario Alberto Pontoriero dice, por eso recomiendo el canal y grupos de astronomía. Y se va mejorando la voz, Daniel. Mucha felicidad de que todo vaya bien. Va mejorando la voz. Y la buena noticia es que me hicieron una tomografía la semana pasada, no sé si no lo saben, y comparando con lo anterior, no estoy peor, lo cual es genial dada la situación. ¿Eh? Es muy temprano para hacer comparaciones entre esta tomografía y la anterior que tiene 6 semanas, pero aparentemente los medicamentos están haciendo su trabajo. Bien. Daniel Barrón desde Lagomar, al firme, esperando noticias positivas. Por lo menos vimos que Escombros hizo el impacto. Sí, vimos que se convirtió en una especie de cometa artificial. Produjo escombros, vimos fotos donde parecía tener una estela de todo lo que en inglés se dice debris, que son escombros realmente. Escombros tanto del aparato, o sea, del satélite, de la nave, como del propio cometa. Pero bueno, no sabemos más nada, ¿no? Miguel Ángel Tetti dice, saludos Dani, ¿cómo va todo? ¿Será que desviaron de manera significativa la órbita? Alfredo Bonet que saluda. Todos esperamos verte bien, gracias Alfredo. Un abrazo enorme. No puede ser, yo estaba pensando hace un rato que esté Bill Nelson, que esté el administrador de la NASA en una conferencia de prensa, no es normal, o sea, él está cuando las cosas son grandes, ¿eh? Cuando son noticias. Esto fue noticia mundial. De hecho, la cantidad de gente que hubo en el canal cuando transmitimos marcó un récord en los últimos meses. Y ellos lo saben que esto es noticia mundial. Entonces, es un buen indicativo. Ahora, tanto una cosa como la otra, ¿no? O sea, tanto que hayan conseguido desviar la órbita como que tengan confirmación de que no. Las dos cosas son noticia. Porque dada la situación de que lo que queremos es saber cómo desviar un asteroide, si no se desvió, ya sabemos que esa no es la forma, ¿no? Y habrá que probar de nuevo. Pero bueno, esa es la idea de crear un poco de expectativa. Y la están creando. Marina Sánchez nos dice que hoy es el día de la Patagonia y del dulce de leche. ¡Qué bueno! No sabía que había un día del dulce de leche. ¿No sabías que había un día del dulce de leche?
No. Ya voy a ir a comprar.
Ya vamos a comprar, ya vamos a comprar para festejar, ¿eh? Qué mejor manera de festejar, quizás con un helado dulce de leche, ¿no? Me encanta el helado. ¿Cómo está Dani? Nos dice Rodrigo Pérez. La verdad me siento increíblemente bien.
Welcome, and thank you for standing by. At this time, all participants are in a listen-only mode until the question and answer session of today's conference. At that time, you may press star 1, unmute your phone, and record your name to ask a question. I would like to inform all parties that today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the conference over to your host, Ms. Gina Anderson. Thank you. You may begin.
Learning from DART and give us an update on NASA's planetary defense program. On the line, the president of the Italian Space Agency, Giorgio Saccoccia, on the Lucia cube, which hitched a ride on DART. Lori Glaze, the director of NASA's planetary division here at NASA headquarters in Washington, D.C. Then we'll have Nancy Giorgio, the DART coordination lead at the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. Finally, we'll hear from Tom Statler, the DART program scientist also here at NASA headquarters. First, we'll hear from the NASA administrator, Nelson.
Good afternoon, everybody. 2 weeks ago, NASA made history once again.
Bueno, ahí tenemos en línea a Bill Nelson haciendo un recuento de que hace 2 semanas atrás dice, bueno, le mostramos al mundo que NASA puede hacer eso, ¿no? Defender a la Tierra. Ah, bueno.
DART, as we call it, it felt like a movie plot. But this was not Hollywood.
Dice, parece que esto fuera una película de ciencia ficción, pero no es Hollywood.
A Falcon 9 carrying NASA's first planetary defense.
Está haciendo la historia de que, bueno, despegó en un Falcon 9 desde la base de Vandenberg. Y luego de 10 meses y millones de millas, lo escrachamos contra el asteroide y tiene el tamaño de un refrigerador, dice, ¿no? Y se fue, le pegamos a 14.000 millas por hora.
Earth-threatening asteroid was discovered. We could see it far enough away. This technique could be used to deflect it.
Si podemos determinar que un asteroide sea un peligro para la Tierra, quizás esta técnica pueda ser valible. Confirma de que efectivamente sí cambiaron la trayectoria. Esa es la noticia.
Dimorphos 11 hours and 55 minutes to orbit its larger parent asteroid, Dimorphos. Since DART's impact, astronomers have been using telescopes on Earth to measure how much that time has changed. Now the team has confirmed that the spacecraft's impact altered Dimorphos orbit around Dimorphos by 32 minutes and therefore successfully moved its trajectory. In other words, DART shortened the 11-hour and 55-minute orbit to 11 hours and 23 minutes, and it moved it in another location. That has been confirmed by the telescopes. It was expected to be a huge success if it only slowed the orbit by about 10 minutes. But it actually slowed it by 32 minutes. Dr. Lori Glaze and the DART team will explain more about how we confirmed that.
Bueno, estaba tuiteando. Discúlpeme que estaba tuiteando. Bill Nelson dice que lo desviaron al final 32 minutos,
international endeavor.
o sea, de su órbita original de 11 horas 55 minutos, pasó a tener una órbita de 11 horas 23 minutos.
To Italian Space Agency President Giorgio
Impresionante,
Saccoccia.
impresionante.
I thank him for his partnership.
Y ahora está felicitando y saludando al socio de la Agencia Espacial Italiana.
After all, the only one we have. This mission shows that NASA is trying to be ready for whatever the universe throws at us.
Esto nos muestra que la NASA está pronta para lo que la NASA, para lo que el universo nos mande, ¿no?
Of the planet. I want to thank you, Gina. Back to you.
Bueno, esa es la gran noticia.
Now we'll hear from the Italian Space Agency President, Giorgio Saccoccia.
Bueno, y ahora él habla
Hello, Giorgio Saccoccia here.
Giorgio Saccoccia,
Congratulate
el presidente de la Agencia Espacial Italiana.
you and your team made really history with the deviation of the
Realmente
asteroid.
hicieron historia hoy, dice ustedes.
Really be proud of as an international endeavor, and I think our planet can feel a bit more safe for the future.
Esto nos hace sentir un poco más seguros en el futuro, dice, ¿no?
Supported this mission. It was a unique opportunity to be the reporter of the event. We can call ourselves this way because our Licia Cube satellite.
Somos como si los periodistas, los reporteros de la misión, dice, ¿no? Somos como los periodistas, los reporteros de la misión.
And the spacecraft learned on its own how to follow DART in its course towards the asteroids. And about 1 hour, say, before the event, it started an autonomous course to be ready to take pictures and be the witness of the event. Licia Cube had on board 2 optical cameras that were supposed to be used to monitor the event, but at the same time to guide the navigation of the spacecraft, which was done taking advantage of the algorithm of artificial
Nos está
intelligence.
contando que llevaba 2 cámaras ese satélite cubo y que 1 hora antes lo pudieron alinear justamente para tomar fotos del momento del impacto.
Just to give an idea, we're talking about
Sí, la órbita de 11 horas y poco es la que lleva el asteroide Dimorphos alrededor del más grande.
speed with respect to the asteroid of 6 kilometers per second, about 4 miles per second. So Licia Cube has to watch the event and then do a flyby of the 2 asteroids and turn to continue monitoring what was happening. It was really something challenging, but when after the impact took place, you can see we have prepared 2 videos. The first one shows the last seconds before the impact, and you can see the change, basically a little change in the little dot, which is Dimorphos, showing the ejection of the.
Bueno, acá se ve en el video, dice justamente la parte de eyección de materia, dice, o sea, de escombros del impacto, ¿no?
The flyby and the turning of the satellite and getting far away. So what you can see in the second video is actually the approaching from 700 kilometers of distance.
Y el segundo video, dice, lo que muestra es la aproximación, dice, ¿no?
Kilometers from from Dimorphos, and then you can see while we're getting more far away of about 300 kilometers. So I believe what you're seeing here is
Oh, qué bueno que está esto.
fantastic. I remember the night when from the control center at the Argotech premises,
Qué impresionante que está.
prime contractor, we started looking at those images. We couldn't believe our eyes that actually we made it, and we made it thanks to this fantastic collaboration with colleagues from.
Dice, lo logramos. Y lo logramos con la fantástica colaboración de la NASA, ¿no?
Thank you.
Héctor González dice, qué ironía, la NASA con todos sus genios para proteger el planeta y los otros genios con miles de cohetes nucleares.
Next we'll have Ms. Lori Glaze.
Bueno, quien va a hablar ahora
Great. Thank you so much, Gina.
es Lori
I'll
Glaze,
just kind of take a
que es
moment to soak
directora de la División de Ciencias Planetarias de la NASA.
Because for the first time ever, humanity has changed the orbit of a planetary body.
En la primera vez dice que la humanidad, los seres humanos, hemos logrado cambiar la órbita de un objeto planetario.
Dimorphos has changed from a period of 11 hours and 55 minutes to a period of 11 hours and 23 minutes.
De 11 horas 55 a 11 horas 23. Le hemos conseguido cambiar 32 minutos de la órbita. ¿Cómo es que estamos seguros de esos números? Dice, bueno, hay todo un equipo detrás de esto para saberlo. Todos nuestros colaboradores han contribuido increíblemente justamente para esto. Hay cientos de astrónomos. A la gente uruguaya que está mirando, hay un astrónomo que está trabajando también con ellos.
The team had been looking at a broad range of parameters for the potential physical properties of Dimorphos, and from those models had estimated we would make a change of between a few minutes and several tens of minutes. And so what you've seen here is that result of a 32-minute change is consistent with the estimates that were made beforehand.
El resultado es consistente con la estimación que teníamos, que podíamos llegar a variarle la órbita desde unos minutos a unas decenas de minutos.
Since DART impacted Dimorphos, 2 weeks ago on September 26th. And if I could pull up my first image, please. We've had observations from around the world, ground-based
está poniendo imágenes, está pidiendo que pongan imágenes de las observaciones alrededor del mundo, dice, ¿no? Tancredi es el uruguayo de la Facultad de Ciencias. Gonzalo, Gustavo Tancredi. Hemos hablado con él hace tiempo.
That same kind of view, but from side on. So you're seeing that ejecta cone kind of facing out to the left. And you can see one arm of that cone pointing down to about 8 o'clock, and then the top arm of that cone pointing up to about noon. And so we can see that cone here from the ground. You also see this really bright.
Para los que nos están escuchando, este desvío es una prueba de dos asteroides que orbitan uno alrededor del otro. Orbitan alrededor del Sol, no son riesgo para la Tierra y el desvío no implica ningún riesgo tampoco en el futuro. Es una prueba para poder determinar si podían llegar a desviar un asteroide y lo lograron.
We're continuing to take images. This is the latest and greatest, hot off the press Hubble Space Telescope image that was
Ahora nos van a mostrar una imagen del Hubble ahora, tomada el sábado.
Is that ejection cone, again, we're looking side on, that bottom arm of the cone is still pointing down to about 8 o'clock, but the top part of that ejection cone has kind of gotten pressed back, again, with that solar radiation pressure. And you can also see that comet-like tail has now kind of...
Ahí lo tenemos. Esto es tomado por el Hubble. Dice, parece una cola de cometa. Dice, pero no solo se ve la eyección, sino sé que se ve un regreso por la fuerza solar.
Really fascinating stuff. The learning is going to continue for a long time to come. And so with that, I'm going to pass it over to Nancy to talk a little bit more about the results.
Bueno, va a hablar ahora
Well, thank you so much. It's
Nancy
really a
Chabot.
pleasure to be here today.
Nancy Chabot
And
es líder de
I
coordinación,
really start by also just acknowledging
el líder de
what
coordinación de
has
NASA
been
Johns Hopkins, el Laboratorio de Física Aplicada.
built the spacecraft from the team who so successfully led that spacecraft to guide itself to that spectacular collision. To really the team that's been working
Está felicitando al equipo por lo preciso que fueron en conseguir justamente
around the world in order to
hacerlo escrachar, hacerlo chocar contra el asteroide.
happy to be here as a representative of that large international team to share that result and to dig into this data a little bit. So digging into the data, one thing I want to stress up here at front is that there are two different types of observational data sets.
Hay dos tipos de observación. Mirando los datos de todo que nos han mandado de todo el mundo, dice,
of 32 minutes for the orbital period change, and they're both completely consistent and supporting this result that we've heard.
todos los datos confirman y soportan los 32 minutos.
Animation, please.
Vamos a ver una animación.
The first data set and method used by the DART team uses optical telescopes here on the Earth.
La primera dice, usa telescopios ópticos desde la Tierra.
Dimorphos and Dimorphos. As it looks to these telescopes, this asteroid system is always just a single point of light.
Dice,
That single point of light
lo que se
changes
ve
brightness with
es
time, as seen by
un punto solo, simple, que varía de luz justamente cuando pasa por delante el otro.
But then other times it actually passes right into
Por delante.
the shadow. This is
La sombra, dice, es la sombra de
so you can see
Dimorphos.
blitz events that the telescopes see a decrease in the overall brightness of this asteroid system every time that this happens. And then you can also see that these eclipse timings are very much related to the orbital period of Didymos around Dimorphos.
O sea, esto sucede cuando crea una sombra el Sol acá y cuando pasa por la sombra del propio Didymos aquí. Esta es la sombra. Y esto es lo que ven los telescopios ópticos. La primera sombra y la segunda sombra. La variación de brillo es lo que se ve.
Hiding behind Didymos or located in front of Didymos at that time, but was actually off to the side. And telescopes on the
Dice, no está al frente, está al costado.
in order to get that timing to inform when the DART spacecraft should show up so that the autonomous navigation system could separate Didymos from Dimorphos and target onto Dimorphos and squarely hit it. And we see that that positional information that the team had was excellent, and Dimorphos was exactly where it was expected from the analysis of this telescopic data. So this is just to say that the team was highly experienced and practiced at already using this method of telescopes to understand where Dimorphos is relative to Didymos. If I can have the next graphic, please. So ever
Vamos a
since,
verlo gráficamente.
the event on September 26th, 2 weeks ago, these telescopes have been observing this system nightly. And that's what you see going across here on this graph on the top. Just this nightly telescopic data, night after night after night after night, all added up there. There's actually 4 different telescopes on the Earth that have contributed to making this graph so far that you're looking at in this.
4 telescopios alrededor de la Tierra han contribuido para poder hacer la gráfica que vamos a mostrar. Dice, observándolo todas las noches del 26. África, Chile.
And all 4 of their data have excellent agreement and are all just overlaying on top of each other right here.
Bueno, y hemos colocado unas gráficas por encima de las otras para alinearlas.
That have looked at analyzing this data separately, and they have come to
Y hemos analizado esos datos totalmente separados.
then showing 2 examples of this much larger data set blown up so you can see the actual data on September 29th and on October 4th. And what you see very clearly in that data is these dips in brightness that we were just talking about with that animation. And these dips in brightness were confirmed by these 2 independent research groups, and they are consistent and indicate that the orbital period of Dimorphos around Didymos currently is 11 hours and 23 minutes. What you can also see here is that it is not consistent with being 11 hours and 55 minutes.
Bueno, lo que se ve acá es que efectivamente no es consistente con la órbita de... O sea que después del impacto no es consistente con la órbita de 1155, ¿no? Y luego lo que vamos a ver ahora son radar planetario de California, dice, ¿no?
Planetary radar is
contrast to the optical telescopes, you can actually distinctly get signal from both Dimorphos and
Lo increíble del radar planetario es que podemos ver señales de los dos cuerpos, de los dos asteroides.
Regularly every night for the last 2 weeks, roughly. And from those, they have also been tracking that this is an 11-hour and 23-minute period currently for Dimorphos around Didymos, with a 32-minute orbital period change. If I can have the last graphic for me, please, here.
Voy a poner una gráfica nueva.
On October 4th and October 9th,
Entre el 4 de octubre y el 9 de octubre consiguieron imágenes directas de radar. Dice, y en la gráfica ahí pudimos obtener señal de Dimorphos, exactamente. Y la posición es concordante con justamente con 11 horas 23 minutos.
So this is a very exciting and promising result for planetary defense to have this orbital period change of 32 minutes. It's within the range of the models that has
Aquí se ve dónde está uno de ellos, dónde deberían estar y dónde estaban. Entonces, ese es lo que esperaban tener para una órbita de 11 horas 55 minutos y lo que realmente obtuvieron, ¿no?
This is a 4% change in the orbital period of Dimorphos around Didymos. And it just gave it a small nudge. But if you wanted to do this in the future, potentially, it could potentially work, but you'd want to do it years in advance. Warning time is really key here in order to enable this sort of asteroid deflection to potentially be used in the future, and it is part of
Bueno, esto lo que demuestra, dice que realmente puede ser obtenido, puede ser este método utilizado para poder desviar un asteroide en el futuro. O sea, esto es una demostración efectiva de que sí se puede hacer. Gerfo dice, ¿no hubo video? Vimos una serie de fotografías que sí parece un video, efectivamente. Y lo vimos en directo. Gracias, Rosa, por estar ahí. Quien está hablando es Tom Statler, es el director científico del programa DART. La verdad no teníamos ni idea de cómo se veía Dimorphos. No había imágenes ópticas. Y esto junto con la forma nos dio una idea de su volumen. Y va a haber muchísimo trabajo también en los escombros que eyectó. La secuencia del impacto la tomó el cubo italiano, que ya lo vimos recién hace un rato. Sí, éxito total, Rosa. Bueno, ¿qué es lo que queremos ver también? ¿Qué tan elíptica es ahora la órbita? ¿Qué tanto se mueve? O sea, si hace algún movimiento extraño ahora el asteroide. Bueno, y lo interesante de todo va a venir también cuando la nave espacial Hera de la Agencia Europea llegue al asteroide y haga su sobrevuelo para poder verlo, ¿no?
Impact changed the motion of the asteroid. How efficiently was momentum transferred? It's too soon to say. There's a lot of moving parts in this calculation, but as Nancy intimated, it looks like the recoil from the ejecta blasted off the surface was a substantial contributor to the overall push given to the asteroid, in addition to the push of the spacecraft directly impacting. And so there's a lot yet to come.
Muy buena pregunta, Mario Alberto, para hacerla.
This is a spectacular image taken from LiCiQ and enhanced by the DART team to bring out fine structures. The rectangles that you're seeing are not real. It's just that in each successive rectangle, the contrast has been boosted by another factor of 2 in order to bring out that faint structure. And this is just
Hola, Adrián, ¿qué tal?
Stunning image. And every little wiggle in those streamers, every little blob, every little particle that you see is a clue to something. It's a clue to something.
O sea, cada partícula que se ve, cada cosa que sale de allí, dice, es un dato de algo, dice, ¿no?
A dozen new questions are popping into your head that you would have never have thought to ask before seeing this. Well, that's just one of the hallmarks of great science. It opens up new questions that we
Bueno,
would never
y cada cosa que ves acá abre nuevas preguntas, dice justamente.
I really love it because it is artistic, it is poetic, and even though those rectangles aren't real, they're suggestive of windows of understanding. We're opening new windows of understanding, looking deeper and deeper and deeper to gain a better understanding of not just how to defend our planet against.
Bueno, y esto nos muestra montones de ventanas haciendo una alusión a los rectángulos que se ven allí, de cómo podemos llegar a defender nuestro planeta en caso de llegar a tener alguna posibilidad de colisión, ¿no?
We do have some reporters on the line, but if there are any questions from reporters in the audience, please grab a microphone.
After the tone, please state your name.
Daniel Regueira.
Thank you.
In the answer session. If you would like to ask a question, please press star 1, unmute to your phone, and record your name. Your name is required to introduce your question as well as your affiliation. If you need to withdraw your question, press star 2. Again, to ask a question, please press star 1.
Bueno, viene el momento de preguntas. Me encantó esa pregunta de Mario.
And I will call on you when I'm ready to ask for questions in the room or on the line. Thank you.
Hi, it's Joel Achenbach with the Washington Post. This is all fascinating. Congratulations. Basic question, is this a plausible, deployable type of technology for deflecting an asteroid based on the results of this test? And also, can you just explain a little bit about why was the change in the orbital period at the high end of estimates? Just what mechanically was happening there? I know you referenced the ejecta and the recoil, but I mean, can you explain the Newtonian mechanics of that?
Bueno, está pidiendo que explique las variaciones de las órbitas, alguna explicación de newtoniana. Si la técnica es válida también para el futuro. Y la respuesta es sí.
Even a potentially hazardous asteroid of this size, using a kinetic impactor technique. As Nancy said earlier, one of the key pieces to being successful with implementing a technique like this is early detection.
Una de las piezas fundamentales para poder desviar un asteroide es detectarlo a tiempo, o sea, bien temprano. Adrián, no se demoró tiempo en recibir los datos. Lo que querían es confirmar los datos con las observaciones terrestres. Querían confirmar la variación de la órbita.
Yeah, thanks. So, period change of 32 minutes is spectacular and exciting, and what the DART team is working on right now to understand. So, the DART investigation team has over 200 members that are on 28 different countries. We've been meeting daily and having really intriguing discussions that
Gracias,
are fascinating.
David Marino, por la donación y ese emoji.
Or get back to the telescopes and do everything that's been going. So this is active. What the team is actively doing.
Bueno, dice que se reúnen todos los días con los astrónomos alrededor del mundo para discutir justamente las observaciones y los temas. Dice, hay más de 200 astrónomos en más de 20 y algo de países alrededor del mundo.
But yeah, come back in a little bit, and we'll be happy to share the results of those models that the team is working on about what specifically is causing that and what that means. Not just for what happened to Dimorphos, of course, but what this means for potentially applying this technique to other asteroids in the future.
Dice, sí, obviamente, el tema de dentro de poco vamos a poder tener toda la información para compartirla. Respecto al tema de la órbita.
Hi, Jenna Biderkoff, your Dye magazine. First of all, congratulations. What an amazing milestone. So the administrator mentioned that in addition to the orbital period changing, that Dimorphos was moved a little bit. Can you go into that and how how the DART impact affected the binary system overall?
So along with changing it, because it still is a double asteroid system, Dimorphos just now orbits ever so slightly closer to Didymos than it used to previously.
Preguntó cómo era la variación que esta chica preguntó la variación que le había influido en la órbita. Y lo que están contestando es que esa variación en realidad lo que hace ahora que Dimorphos está orbitando un poco más cerca al otro asteroide. O sea, redujo el tiempo porque redujo la velocidad y ahora está más cerca del otro, nada más, ¿no?
Thank you. We have one more in the room, and then we'll take questions on the line.
Una pregunta más de los periodistas que están presentes ahí y luego van a empezar a tomar preguntas a los que estamos conectados.
There being a greater plume of ejecta imparting more momentum. Is that result generalizable now, do you think? Does that mean that, that you'll factor that into your models moving forward and you think more asteroids are generally like this that are of concern? And secondly, what would be your next, what would you like to see as the next move?
¿Cuál va a ser la próxima movida? Le dice, ¿no? La próxima movida es Hera, obviamente.
Of course, this is one test.
Dice, esto es un test, dice, ¿no? Un test en un asteroide.
Every time we send a mission to another asteroid, is we learn that each asteroid has a different part of the story of our solar system's past.
Cada asteroide tiene su parte de historia en nuestro sistema solar. Cada asteroide que está en distintos lugares tiene distintas historias. Tiene distintas historias.
Rubble piles like Bennu, for example. We know that there are objects with diverse surfaces.
Sabemos que hay objetos con distintas composiciones o superficies. O sea, no quiere decir que el test que hayamos hecho ahora con este sea aplicable a todos los asteroides.
For our physics calculations and our simulations that tell us how different kinds of impacts in different situations should behave, we anchor it with this bit of ground truth, and then that tells us how better to extrapolate to other situations.
And if I'll just add one thing before I'll pass over to you for the next steps. I think one of the things that's really interesting here, too, is that Dimorphos is a size asteroid that is a priority for planetary defense, this sort of 160-meter sort of object. And it's the first time we've been to an object that size and seen how it reacts too. So I think that's another important point.
Sí, realmente el tamaño de esto es interesante. ¿El cambio de órbita es definitivo? Dice Germán, sí. Pero es muy bueno para agregarlo a la pregunta.
What would be next? And I think there's two things that are really important here. And you heard Tom say that, this is one test on one asteroid. And in this case, it appears that particular asteroid may be this kind of loose collection of debris out of material. But not all asteroids are like that. Some may be a solid rock as opposed to a collection of smaller rocks held together. And the way they react is going to depend on whether they are solid or whether they're these collection of rubble.
Bueno, ¿cómo reaccionan los asteroides a un golpe de estos? Realmente depende de la composición, si es una roca sólida o si es una aglomeración de tierra, ¿no? En realidad, podríamos llegar a mandar una misión para investigar qué tal es y luego sí considerar otra misión para ver qué es lo que tenemos que hacer.
Complete our inventory of these objects in the solar system that are potentially dangerous to Earth. Again, from this size category of about 140 meters and larger.
Dice, inclusive, ¿qué es lo primero que vamos a hacer también? Es tratar de completar nuestra base de datos con todos los asteroides que miden 140 metros o más y que pueden ser potencialmente peligrosos.
Just want to confirm that Mr. Giorgio Saccoccia is still on the line as well?
Yes, I'm here.
Awesome. Thank you. All right. Operator, can we please have our first question from media on the line?
Yes, Ms. Marcia Dunn, your line is open, and please state your affiliation.
Yes, hi, Marcia Dunn, Associated Press. Thank you for this. When did you find out, what day, that you had achieved this 32-minute orbital?
Associated Press está preguntando ¿cuándo pudieron confirmar esto de la variación de los 32 minutos de la órbita?
And what if Nancy and Tom could both say what their reactions were upon first learning of this 32 minutes?
¿Y cuáles fueron sus primeras reacciones al poder descubrir esto?
We had been saying the telescopes would need time in order to do this measurement, and indeed they did. But I think this is really credit to the enthusiastic international team that we have that got on this so quickly, both from the optical telescopes and from the radar observations.
En realidad, todo este logro de la confirmación es por la cantidad de gente de ese team alrededor del mundo que está unido a la NASA para lograr esto, ¿no?
And I think it's that enthusiasm and that teamwork that, we share ideas on there. And so it's hard to pinpoint exactly when maybe the team, had complete confidence in this result.
La verdad no tengo idea exacta de cuándo obtuvimos la confirmación exacta.
Yeah, maybe I'll speak to the other half of the question. So as Lori said earlier, the team before Impact has been spending years trying to understand the range of possible outcomes of this experiment, not knowing what the target was going to be. And so they did simulations on solid rocks and broken rocks and fractured rocks and piles of rocks and rubble piles and piles of gravel. And there was this immense range. And one of the things we did understand from those simulations.
En realidad, antes de todo este estudio, no sabíamos exactamente cómo era el asteroide, si era sólido, era en roca o no. Dice, de ahí que nuestras simulaciones variaban.
But the last few minutes before impact on the 26th were quite dramatic. And when I saw Dimorphos come into view, and when I saw there was not a single crater on it, and there were a lot of what appeared to be loose rocks, and this was a totally non-scientific by-eye measurement, I looked at it and I said, this is not going to be 73 seconds.
Cuando lo vi en el momento del impacto, que aparecieron esas imágenes y que vimos que era roca, dijimos, bueno, esto no son 23 segundos.
Yes. Jeff Faust, your line is open, and please state your media affiliation.
Good afternoon, Jeff Faust of Space News. I know one of the
Space
factors
News, Jeff Faust.
leading up to the impact was measuring beta, the efficiency of the impact on the asteroid. Do you have like a range of beta values that are consistent with this 32-minute orbital change that you've seen? Thanks.
I'll start and Nancy can chime in. Nancy knows beta is my favorite subject. So we're going to be working really hard to get a beta. It is, as we said, it seems virtually certain that the ejecta were a significant contributor to the...
¿Qué tamaño tiene Jorge Pitalá ese asteroide Apophis? Interesante eso.
add anything to that?
No, I'm just happy that people are asking these questions and so interested, and that'll motivate the team even more to get to work and come back at you with an answer once we've run some more of these models.
I think they're working now.
Okay, I understand we have several questions on the line, but I wanted to check in the room to see if we had any additional questions. Okay, operator, let's have our next media question.
Thank you. Sarah, your line is open. Please state your affiliation.
Hi, this is Sarah Scholes for the New York Times. I was hoping you could say a little bit
New
more
York
about what
Times.
the continuing follow-up observation plan looks like, and a little more about what you hope to learn from that campaign. Thank you.
So the observational campaign for the DART team will continue. The timing of DART's impact into Dimorphos was actually chosen when the distance between Earth and this asteroid system is at a relative minimum. And so observations can actually continue into early 2023. So right now we have this orbital period.
¿Cuánto tiempo van a seguir observándolo? Dice, lo vamos a seguir observando mientras esté cerca la Tierra y eso es hasta principio del 2023.
In addition, the tail is spectacular. This amount of ejecta.
Mientras, dice, la cola es espectacular y está variando. Así que seguimos observándolo para poder registrar todo eso, porque es increíble. Los próximos meses, dice, van a ser increíbles, seguramente.
Can we have our next question from media on the line?
Daniel, your line is open. Please state your affiliation.
Hi, this is for Adron Uruguay from Uruguay, Spanish audience. Thank you and congratulations for all the NASA team. My question is, what is the largest mass that we could impact on an asteroid, and what technological limitations do we have to do a deviation? And the other one is the change permanent, the orbit change we made to Dimorphos? Thank you.
Can we ask to have you repeat the question, please? There was a little bit of feedback in the room.
Okay, what is the largest mass that we could impact on an asteroid, and what are the technological limitations do we have? And the other one, the second question, is if the change of the Dimorphos orbit is permanent or not.
And it's the largest mass that we can impact.
Well, I heard the end of the question. It is a permanent change, although we have done more to the system than simply change the orbit. We may have left Dimorphos wobbling a bit. So over time, there may be some interaction between the wobble and the orbit, and things will adjust, but it's certainly never going to go back to the old 11-hour 55.
Nunca va a volver atrás a la órbita. Okay, the other one was the largest mass that we could impact.
Large of a mass, and I think there's a lot of factors in play there in just how large or how far this technique could go.
Yeah, and I think there's some studies out there, and the National Academies of Science decadal survey had planetary defense included for the first time, and it really is related to the mass of the asteroid, but then the x-axis is always warning time. It's always how much time you have to deal with this. So if you find the asteroids ahead of time, it's very reliable that NASA and other space agencies can have decades of warning time, can track these things reliably for 100+ years. And so that's really lets you deal with larger objects if you have that warning time. So I think I just want to stress, this is spectacular that we've taken this first step for a kinetic impact or deflection to potentially be used in the future if we need to. But we really need to also have that warning time for a
Claro, lo que necesitamos es tener. Thank you.
Excellent, thank you. I understand we have several questions on the line.
Lo que necesitamos tener es justamente un aviso temprano para saber cuál es la masa más grande.
Sure.
Bueno, las preguntas fueron relativamente contestadas, ¿no?
The NEO surveyor mission, and I had a question about that. I had read, and correct me if I'm wrong, that we know of about 40% of the asteroids that can cause regional devastation. How was that statistic? How did we come up with that statistic?
I'll give you my stab at it, and then Tom can correct me. How's that? By looking at the population of asteroids that are out there, we have an estimate of how many there are. There's a size distribution. We can see the various sizes of the different asteroids that are in these near-Earth orbits. And so we have a prediction and an estimate of how many we should see at each of the various size ranges. So for those objects that are a kilometer or larger, the really big ones, we've actually identified, I believe it's like 99% of those. They've been identified. We don't believe there's that many more of them out there that we haven't found. But when you get down into this range of about the 140 meters and larger,
Dice,
as I said,
si estamos hablando de los asteroides grandes, dice más de 1 kilómetro, dice los tenemos identificados al 99%. Pero cuando empezamos a reducir el tamaño a tamaños de 140 metros como 160 tiene Dimorphos, dice en realidad ahí sí no lo tenemos a todos categorizados. La respuesta a la pregunta fue que el cambio de la órbita es permanente. ¿Sí? No sé si lo dije cuando lo estaban contestando.
What are the range of asteroid sizes, and also what are the distribution of orbits in the solar system? And we also know for each one of those surveys, what are their capabilities, right? What are they able to see at what distances? So for every observatory, we can figure out how efficiently they're able to detect an asteroid of this size on this kind of an orbit and so on. And so knowing from that how incomplete the discoveries are, you can work backwards and figure out what has not been discovered yet.
Great. Any other questions in the room? Okay, operator, can we have a couple more questions on the line?
Gina, your line is open. Please state your affiliation.
Gina Sinceri, ABC News. How important was that this be an international cooperative mission? What did that add to it?
I'll take a first stab at that one. I think that's incredibly important. As you can imagine, of course, planetary defense is not just a problem for the United States, nor is it a problem just for the Italians that cooperated on this mission. But this is a planet-wide issue that if there were an asteroid that were a threat to Earth, we should all be concerned, and we all need to be working together to identify the asteroids, which we do with our ground-based programs, the entire world, with telescopes around the world looking for these objects.
Bueno, le está preguntando, le está diciendo en realidad que lo que tenemos que hacer es justamente caracterizar a todos los asteroides, traquearlos, trabajar con toda la comunidad internacional, que es lo que tenemos que hacer para la defensa planetaria.
If you like, Giorgio Saccoccia here, I can add something to
Please do, Giorgio.
Y Giorgio va a agregar algo.
I can only confirm, of course, that protecting our planet is from space and from ground to threats that come from space is by definition something that we have to do together. And for this reason that
La defensa planetaria, por definición, dice Giorgio, es algo que tenemos que hacer entre todos.
it has been mentioned ground-based observatories that would monitor our environment. For example, here from Italy, we have developed ad hoc telescopes that works as the fly of an eye, eyes of a fly, so composite mirror and lenses.
La segunda pregunta la omitieron un poco. En realidad fue la primera que la leímos después como segunda. Y creo que no la omitieron, sino que no la entendieron del todo bien. Y ahí juega gran parte la mala calidad de mi voz, que nos está jugando en contra para poder participar de estas conferencias. Pero quiero hacerlo tanto esto que no me aguanto y lo hago igual.
By the way, we took 720 and more pictures in those 10-minute observations. I'm sure that scientists will be working on those pictures for a long time to get the best out of what we have done together with NASA.
I have no doubt about that, Giorgio. Fantastic data set. Can I also add that, just from an international perspective, that the next mission to fly to the Dimorphos system is going to be
Estas son las imágenes de los italianos, ¿eh?
That is being planned by the European Space Agency. Again, a multinational.
En el acercamiento y en el alejamiento, en el momento del impacto. Está la distancia y son frames. Es como si fuera una película en realidad, ¿no? Pero son cuadros de fotografía de 2 cámaras que llevaba a bordo el satélite cubo italiano.
Marvin, your line is open. Please state your affiliation.
Hi, good afternoon. My name is Marvin Marshall from the Nighttime.
Gracias, Hernán.
Here on Twitch.tv.
¿Tiene algún problema de audio ahí? Puede ser, sí, puede ser.
Whoever wants to answer this, with the data that we received from this mission, how does this scale up, and to what size? Would this mission give NASA now the confidence to send, a whole colony?
Adrián Braga dice que no sabían qué decir. No, si no lo saben dicen que no y que te contestan después. No evitan las preguntas. Pero puede que los estaba ofendiendo, sí.
I'll start it and pass it to you. So we have a physics understanding of how impact should scale with size of target and size of impactor and velocity of impactor. If we are ever in a situation where we have to actually deflect an asteroid, we'll want to look at the situation very carefully, because any such event would be very situational. It would depend on the orbit of the dangerous asteroid, the nature of the asteroid. We would want to find out as much as we can about it, the accessible trajectories, how could we get there, how soon could we get there. All of these things play in before you can even begin talking about, well, should we use one large impactor or several smaller impactors.
Dice, antes de ver si necesitamos algo que impacte más fuerte, más suave o algo, primero tenemos que tener bien claro los tamaños, las trayectorias. Dice, de repente no necesitamos un gran impactador porque puede llegar a romper la roca en partes, y lo que menos queremos de un asteroide que sea un peligro es romperlo en pedazos.
ready-to-go capability you want to have, that's more than a science question, more than an engineering question. It's really a policy question.
Sí, dijeron eso Germán Ramos, que no va a volver a su órbita original, pero que pueden interactuar entre ellos y pueden cambiar, sí.
Which asteroids can we defend ourselves from with this technique is we need to know how, when.
Ahora cuando terminemos la conferencia vamos a escuchar lo que se decía. Vamos a volver a escuchar la pregunta. José Fernández, que recién llegas, mira el primer mensaje que está pineado en el chat. Ahí tenés la respuesta.
Which asteroids can we defend ourselves from with this technique?
Steve, your line is open. Please state your affiliation.
When we need to find them, we need to identify them, we need to characterize.
Hi, my name is Steve Gorman, Reuters.
The single most important factor in being able to implement any technique.
Hello?
Excellent, thank
yes,
you.
Your line is open.
Yeah, my name is Steve Gorman. I'm with Reuters, and I wanted to know what combinations of telescopes, if somebody could run through sort of which combination of telescopes, ground-based telescopes and space-based telescopes, if they were also involved, were involved in confirming the results of the DART test.
So the telescopes so far by our team in order to get this result are Las Campanas Observatory in Chile, the Las Cumbres Observatory Global Telescope Networks in both Chile and in South Africa, and the Danish telescope in Chile, as well as the two planetary radar facilities of Goldstone Observatory in California and the Green Bank Observatory.
Estaba preguntando cuáles son los observatorios incluidos, telescopios, pero los que pudieron ver
monitoring this. There's
Dice,
actually
son
more
los dos
than
de
3
Chile, el de
dozen
Sudáfrica
here on the
y
East
los
Coast as
radares
well,
de California.
and 3 telescopes in space that are also contributing.
Pero
So I
también
really
tenemos
would
3
direct you
telescopios
to the
en el
DART
espacio
website
que
for
han
that full map
contribuido.
of all of those telescopes and their locations. This is a very initial result where we've had contributions from
Esto es
highlighting
muy inicial también.
but many more facilities are
Hay
contributing to
muchos más lugares que están contribuyendo a esto.
Note to that, you'll notice that the observations so far have predominantly come from observatories in the southern hemisphere. This is because Didymos
La mayoría son observaciones del hemisferio sur ahora. Pero la próxima semana van a ser accesibles a los observatorios del norte del Ecuador.
Two more. So, operator will take one in the room. Please come to the mic, state your name and media affiliation.
Hi, it's Sam again from ASP. Nancy, just on the breakdown of the telescopes again. The first 4 you mentioned were all optical, then there were a couple of radar. Does radio also have a part to play, or potentially, or in addition to that, or is that not the case? Sorry, it's a kind of a technical question.
No, I mean, there's a lot of different things. I mean, really today we've been focused on this period change result, and so those are the 6 that have contributed to that result for the team.
Okay, great. We'll take 2 more on the phone line. I understand we have more.
Jeff, your line is open of NPR. Please state your full name.
Hi there, Jeff Brumfield with National Public Radio. Thanks for taking my questions. I had 2. One was, so am I understanding that there is no sort of follow-up SMAC and asteroid mission with a bigger impactor or any sort of plans for follow-up missions along the lines of DART, that this is it for now? And then secondly, could you explain a little more about how the ejecta helped the asteroid move? So what was the mechanism when the impactor hit? Why did this additional ejecta come off, and how did that move the asteroid?
Estaba hablando sobre la trayectoria original, sobre lo que el momento del impacto, el escombro hacia donde fue.
The DART mission was an incredible demonstration of this first ever test of its kind. We certainly want to make sure we analyze the data and really understand very well.
Sí, ha sido increíble esta misión, dice, y tenemos que realmente seguir entendiendo un poco más.
Demonstrations that could occur in the future, either of this technique or other mitigation techniques.
O sea, no solo de esta técnica, sino de esta y otras que puede haber para el futuro.
We have a decadal survey that the National Academies provides to us, and as Nancy said, planetary defense was an important part of that National Academies
El sistema de defensa planetario, dice, es parte de la academia que está trabajando en esto, ¿no?
That we should be focused on in the coming decade within planetary defense. And those highest priorities are, first of all, as we've noted, the ability to be able to detect and characterize these objects, that being the single most important factor that we need to know, is which ones out there are potentially dangerous and when might they be.
Lo que tenemos que aprender es cuáles son los más peligrosos y, o sea, potencialmente peligrosos. Esa es la prioridad.
Was that we should explore and look into a mission that could be a rapid response.
Entonces, tenemos que tener tenemos que reconocerlos primero, hacer una misión de reconocimiento y luego, o sea, tenemos que saber si es una roca sólida o es una aglomeración.
And so those are the next 2 highest priorities within planetary defense.
Thank you. We'll take one more question on the line, and then I'll make closing remarks.
Thank you.
Francisco Navarro, gracias por estar ahí. No lo veo tensos. Adrián.
Hi there, Megan Bartels from Space.com, and thanks for taking my question. This is particularly for Nancy, but if others want to chime in, that's great. Those fabulous images that you showed from Hubble and others, how does the ejecta and plume that you see there compare with sort of the most dramatic scenario the team had hoped for? And did that debris at all complicate the orbital measurements to determine that 32-minute change? Thank you.
Hugo Pérez, sí, el CubeSat, por lo que yo sé, pasó de largo. No sé cuál es su destino final. pero lo que van a mandar es Europa la sonda Hera, que se lanza el año que viene, creo, y va a ir, entre las cosas que va a hacer, lleva espectrógrafos, va a analizar la superficie, va a fotografiar el sitio del impacto, o sea, va a hacer un montón de mediciones que van a seguir sirviendo para validar la misión DART. El tema de los escombros que Larga está comentando ahora va mucho más allá de los cálculos que podemos hacer.
Excellent. Thank you so much, everyone, for participating, especially our speakers here at NASA headquarters, and also Mr. Giorgio Saccoccia, who is joining us on the line, and media who came to attend.
Thank you, NASA, for all your support. Thank you.
You can go to
Have a nice day.
nasa.gov/start, and also follow us on social media. For additional media questions, if you did not have the opportunity to ask questions either in the room or on the phone, please follow up with Josh Handel, who's here over there, and he'll be happy to answer any questions before the deadline.
Cortamos la llamada. Vamos a poner el audio.
And media who came to attend here today. For more information about the DART
Bueno,
mission,
esto,
you can go to
ahora sí estamos con el audio de lo que...
and also follow us on social media. For additional media questions, if you did not have the opportunity to ask questions,
Vamos a ver si logramos de alguna manera encontrar la pregunta.
Well, I heard the end of the question. It
Uy, sí, mi voz sale horrible, ¿eh?
Daniel, your line is open. Please state your affiliation.
Hi, this is for Adron Uruguay from Uruguay, Spanish audience. Thank you and congratulations for all the NASA team. My question is, what is the largest mass that we could impact on an asteroid, and what technological limitations do we have to do a deviation? The other one is the change permanent, the orbit change we made to Dimorphos? Thank you.
Can we ask to have you repeat the question, please? There was a little bit of feedback in the room. Can you repeat the questions again, please?
What is the largest mass that we could impact on an asteroid, and what are the technological limitations that we have? And the other one, the second question, is if the change of the Dimorphos orbit is permanent or not.
Understand it's the largest mass that we can impact.
Well, I heard the end of the question. It is a permanent change, although we have done more to the system than simply change the orbit. We may have left Dimorphos wobbling a bit. So
Le hicimos más que un cambio de órbita permanente. También le pusimos una especie de, le inducimos una especie de, en inglés se dice wobble, que es un tambaleo, ¿no? En su movimiento.
over time, there may be some interaction between the wobble and the orbit, and things will adjust, but it's certainly never going to go back to the.
Dice, muy probablemente va a haber una interacción entre los cuerpos, entre el cambio de órbita y ese bamboleo, y si en el futuro la órbita se ajuste, pero definitivamente no va a volver a ser lo que era antes.
The old 11-hour, 55-minute orbit. So
Nunca va a volver atrás a la órbita.
O sea, nunca va a volver a tener esa órbita de 11 horas 55 minutos.
And I think the other part of your question had to do with the mass and how large of a mass. And I think there's a lot of factors in play there in just how large or how far this technique could go.
Yeah, and I think, there's some studies out there and the
Bueno, ahí entendieron qué tan grande es la masa y ahora estaba hablando de que hay técnicas allí y empieza a hablar de SETI, ¿no?
National Academies of Science decadal survey had planetary defense included for the first time. And it really is related to the mass of the asteroid, but then the x-axis is always warning.
Y acá se va a la masa del asteroide y dice justamente que depende mucho de qué tanto tiempo tenemos.
NASA and other space agencies can have decades of warning time, can track these things reliably for 100+ years. And so that's really lets you deal with larger objects if you have that warning time. So I think I just want to stress this is spectacular that we've taken this
no a
first
la
step
masa de
for
impacto.
magnetic impact or deflection to potentially be used in the future if we need to.
Y ahí tenemos que ver
But we really
cuál
need
va a
to
ser el
also
impactador que necesitamos para eso.
for a
Pero lo que
technique like this to
necesitamos
be
es tiempo para poder ser
Excellent, thank you. I
efectivos.
understand we have several questions on the line,
Bueno,
but I wanted to check back in the room to see if we had any other questions
increíble
in the room.
que tengamos esa oportunidad de preguntarles, que tengamos la oportunidad de que ustedes hagan las preguntas y justamente la responda la misma NASA tal cual como queremos, ¿no? Bueno, creo que la noticia es increíble, ¿ah? Que esos 32 minutos que han logrado desviar el asteroide, creo que es espectacular. Es un primer paso, es histórico. Vimos la historia, vimos parte de la historia, la disfrutamos juntos y la vamos a seguir disfrutando. Quiero agradecerle a todos los que están como siempre en el canal. Les recuerdo, a medianoche, quizás a la 1 de la madrugada, tenemos un lanzamiento desde Japón, un cohete Epsilon de 4 etapas, va a poner satélites para Innovation. Vamos a transmitirlo, tenemos el streaming, ya está. Si dejan abierto este streaming, lo guía directo. Si no, lo buscan en el canal que ya está. Leo los últimos comentarios y nos vamos. El Usabal dice: qué gran avance, la verdad un bien para todo lo que habitamos este bendito planeta. Qué genial poder ver esto. Gracias, Dani, por mostrarnos los avances de la ciencia espacial. Gracias a ustedes, obviamente. Acá hay alguien que comenta y dice que algunas veces me deprime que la NASA y otras corporaciones estén haciendo este tipo de proyectos de defensa planetaria y que yo no contribuya en absolutamente nada. Bueno, podés contribuir, podés estudiar, podés prepararte y podés ofrecer tu ayuda, que seguramente la van a tomar. Los más de 200 astrónomos alrededor del mundo que están trabajando y colaborando con la NASA no están cobrando. ¿Ah? Sí, es que mi voz juega en contra también, ¿eh? Mi mala voz juega en contra. Gracias, Daniel, dice Adrián Braga, Rodrigo también, Manu Varela, Mario Alfonso Lazo también. Hasta la próxima. Bueno, nos vemos como siempre. Un abrazo enorme. Luz Abay, gracias. Y gracias, Rosa, por estar acá. Recuerden, lanzamientosespaciales.com, página amiga que tiene toda la información referente a lanzamientos. Lo mejor que hay. Y ahora sí, Scotty, nos vamos. Hasta Jaxa.